So with question 10, we've been asked to complete each ordered pair so that it is a solution of the given linear equation. And this is very similar to what we've looked at already in question 8 and question 9, only notice this time, while we're still given an equation, in this case x minus 3y equals 6, the ordered pairs that we've been given are missing one of the coordinates. It's either missing the x coordinate or it's missing the y coordinate, and it's going to be our job to find that missing coordinate. So let's take a look here at the first ordered pair that we've been given. So we've been given the ordered pair, well, blank, comma, 1. So to identify, once again, we know that the first coordinate in an ordered pair is the x, the second coordinate in an ordered pair is the y. So looking at it like this, with our labels x and y, we can see clearly that we are missing the x coordinate. So it's going to be our job to find that missing x based on the fact that we've been given a positive 1 for y. So using the equation x minus 3y equals 6, to find this missing x value, what we have to do is plug in to this equation what we were given. So in this case, since we were given the y value, the y coordinate, let's plug that in and find the missing x. So we're going to have x minus 3y, but again, because we've been given a value for y, in this case positive 1, let's plug that in and see what happens. So cleaning up the left-hand side here, we're going to distribute. So we have we have x minus 3, right? Because negative 3 times positive 1 is negative 3, equals 6. And we want to solve for x. So how do we move that x from the left to the right? Well, we've got to add it to both sides, and that is a terrible color. So let's not use yellow. How about we use something a little easier to see? How about orange? That's a little better. So when we add 3 to both sides, we can see here that negative 3 plus 3 goes away. So the only thing we have remaining on the left is an x, and on the right we have 6 plus 3, which gives us 9. And so we just found the corresponding x value, which in this case is positive 9. So let's go ahead and enter that into our answer. So the first ordered pair is 9, comma 1. So we've just completed the first ordered pair, and we're ready to take a look at the second ordered pair. So let's go ahead and create some room here. So I'm going to go ahead and get rid of some of this work. So we will erase, 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 and see what we have. Alrighty. So looking at the second ordered pair, we have been given the ordered pair 12, comma, blank. So in this case, we were given the x coordinate, and we need to find the y coordinate using the given equation. So this time, anywhere we see an x in the given equation, we're going to substitute 12 in. So right where that x used to be, now lives a positive 12 when we substitute, minus 3y equals 6. So let's clean up the left-hand side, and we know that the coefficient of that set of parentheses is a positive 1. So when we distribute, positive 1 times positive 12 is still 12. So we have 12 minus 3y is equal to 6. So let's go ahead and clean this up just a little bit. And we know the first thing to do to start to isolate this y value is let's subtract 12 from both sides. Doing that will yield, well, 12 minus 12 is gone, so the only thing we have remaining on the left is this negative 3y is equal to, and here on the right, 6 minus 12 gives us negative 6. And for our final step here, we will isolate the y variable by dividing both sides by the coefficient, negative 3. So negative 3 divided by negative 3 is gone. So the only thing we have now on the left-hand side is a y equals, and here on the right-hand side, negative 6 divided by negative 3 is going to be positive 2. We know a negative divided by a negative always yields a positive, and so in this case, when we complete the ordered pair, we end up with 12, comma 2, And there we have it. Now, one of the nice things with these is that we can actually check ourselves, right? So let's go ahead and I'm going to erase all of the work here and show you how you can check yourself to definitively make sure that you have the correct ordered pair, that the 9 for the x coordinate is correct in this first ordered pair, and that the 2 is a correct y coordinate for the second ordered pair. So just like before with question 9, what we can do is plug in both the x and the y into this given equation at the same time to see if we get a true statement. So we're going to test this second pair, the second ordered pair, 12 comma 2. So in the given equation, x, but we're going to substitute in a 12 now, minus 3y, but let's plug in the y value that we just found, in this case 2, and see, does that in fact equal 6? Well, again, there's a positive 1 as the coefficient on the outside of this set of parentheses, so when we distribute here, positive 1 times positive 12 is still 12. Let's distribute here. Negative 3 times positive 2 is negative 6. Does the left-hand side equal positive 6? Well, yeah, it sure does, right? Because what's 12 minus 6? That does, in fact, give us 6. So we end up with 6 equals 6. Is that a true statement? It sure is. So what we just did is, although they weren't asking us to plug in this point, they were asking us to find the missing coordinate. Once we found the missing coordinate, in this case the y coordinate of 2, we could take the entire ordered pair, plug it into the equation, and test. And if we get a true statement, that's how we can confirm that the 2 we found earlier is correct. And we could do the exact same thing with the first ordered pair here, this 9 comma 1. We could take it, plug it in, and see what happens. So let's go ahead and do that just to confirm that in fact our first ordered pair is also correct. So we'll erase some of this work here. We'll get rid of this ordered pair. And we want to test now the entire ordered pair. So this 9 and this 1. So x minus 3y equals 6. Well, we know that the x is going to be 9 minus 3 times y. But y in this case is 1. And does that equal positive 6 when we clean up the left-hand side? Well, there's a positive coefficient of 1 here on the outside, so when we distribute, positive 1 times positive 9 gives us positive 9 still. When we distribute here, negative 3 times positive 1 is minus 3. Does this equal positive 6 on the left-hand side? Yeah, it sure does, right? 9 minus 3 is positive 6, and so when we say, does the number 6 equal the number 6? It sure does. That is a true statement, and so we know without a doubt that when we did the work earlier to find this missing value of 9 in this ordered pair, we can test to find out whether or not we're correct by plugging in the entire ordered pair into the given equation, and here we have a true statement that we end up with, and so we know definitively, because we got a true statement for the first ordered pair and we got a true statement for the second ordered pair, that our algebra is correct. We found the correct missing x and y coordinates for number 10.